Hey everyone, welcome in. We are on the end of week 5. So we're going to finish talking about the while loop today, and then we'll introduce the for loop. We're gonna start off with a class exercise actually, and then end off with the same exact class exercise. This is because the while loop and for loop, you can write a while loop as a for loop and vice versa. As you'll see in programming, there are multiple ways of doing the same exact thing. There's a lot of different ways you can structure loops. So yeah, we'll see 2 of the same class exercises today. Okay, and then yeah, it's really gonna feel the same as 2 days ago. Two days ago we talked about the while loop, and we introduced like a compound interest simulator. We're going to do the same exact thing with for loops, just to further solidify and so people see how to do things in a different way. All right, so yeah, today it's just going to be these 2 things where we're going to be done with these 3 sections. This is in the supplementary reading. If you go to this reading over here, it's going to cover these first 3 over here. All right, and if folks need some more practice, I highly recommend towards the end of lecture, maybe checking out 2.3 over here, 2.3, and then towards the bottom of here, towards the bottom of this section, there's a nice project that will give you a lot of practice. Let me see. It is quite a dense chapter, but if you scroll to the bottom of 2.3, there's a nice programming exercise that will help exercise these things. So yeah, folks can take a look at this later. I'll refer to this in a bit. All right, so that's today. Next week, we're gonna apply the loops to some more real life scenarios. This week, we're just kind of introducing the syntax and the structure, how it works. Next week, we're gonna be finally applying it. Once again, this is the tricky part of class, but hopefully people stick around for here. I'll think of some supplementary material for these in just a bit. The readings over here don't have too much supplementary material on common algorithms, so I'll look for them more. All right, but anyways, let's start off with a while loop warm-up. Last class we talked about the while loop. We went through like 3 different types of them. Let's do a quick warm-up. So the class exercise here is to see if you can write a loop that makes a number bigger, pretty much. All right, let's take like 5 to 10, 15 minutes to do this. You can do either of these loops. I would start off with the first one. Once again, the goal of this loop is to see if you can make a number bigger and bigger. So for this first exercise, write a while loop that computes the sum of all even numbers. This is saying write a while loop that calculates 2 plus 4 plus 6 plus 8 all the way to 100. So if you add those up, it's going to give you some number. All right, if you could simulate that in a while loop and print out the result, that would be the class exercise. All right, so yeah, feel free to pause the video because we're going to take like a 10-15 minute intermission for folks to try this out. All right, and then if you're done early, there is another one here. Feel free to do this one as well. It's the same type of exercise. Write a while loop that makes the number bigger. However, this one is a different calculation. It's asking to find out what is 1 squared plus 2 squared plus 3 squared all the way to 100 squared. So if you add all of those up, it's going to give you some number. And yeah, you could represent this in a while loop. You could use a loop to compute this result. All right, so let's give it like 10-15 minutes. This is a chance for folks to think about it. At least try it out and see where you can get. All right, so yeah, let's take 10-15 minute break. I mean, not break, an intermission exercise. And yeah, for folks in the Zoom chat, feel free to let me know if there's any issues. I'd be happy to take a look. 15-minute timer. Let's make it. All right, in 15 minutes, we'll go over a couple of possible solutions. Okay, I want to pause the recording here. All right, folks, we are back from intermission. Hopefully people gave that a try and maybe got some progress on the first one at least. Here, let's go through this one together. We're gonna see a couple possible solutions. I would call this while loop warm-up. So let me call it while loop warm-up. All right, let's set this up. Okay. All right, let's do this first one. The first one is asking to kind of add 2 plus 4 plus 6 all the way to 100. There's a lot of different ways you can represent the solution. One way that's kind of easier to think about is kind of keeping track of two variables. You can imagine like we're keeping track of a sum. So here I'm initializing a sum to 0. The goal is to make this number bigger in a while loop. So you could make a while loop that iterates from 2 to 4 to 6 to 8, and then use those numbers to accumulate into this variable. All right, so you can think of it as you're maintaining two variables. You're maintaining the result and also another variable, like you can call it counter. I'm gonna initialize it to 2 for now. All right, so this is one way you can think of the problem. We have a variable, the big variable, and then we have another variable that's meant to iterate. All right, so we do want to go from 2 to 100. So I'm gonna get a while loop here because we want to go from 2 to 100. And since we're stopping at 100, you could say keep doing the loop when we're underneath 100, when we're underneath or equal to. All right, so for now, let me go ahead and this is an infinite while loop, by the way, folks. It's an infinite while loop because this statement is always true. This expression is always true. So I'm gonna increment counter here. I'm gonna say counter is equal to counter plus 2. All right, this will make it so the condition becomes false at some point. All right, it's gonna become false when counter becomes 102. Okay, so let me go do a print statement real quick, just so folks see what this loop is doing. So do a print statement. I'll say counter is currently some digit in a new line, and then for the decimal number, I'm gonna put counter, because counter is gonna be substituted into this decimal number. Okay, so let's go ahead and see this. Oh, I need a cd change directory, and then Java while loop warmup. Okay, cool. I just ran it. It was really fast, but I have like 50 lines here. Let's sanity check it. So the first print statement said counter is at 2. Okay, this makes sense because it initialized, and then counter increases. We check the condition, it's still true. So then we do another print statement down here. So yeah, it's gonna loop over and over again. Counter all the way becomes 100. So counter becomes 100 in the last iteration. This is true, so we print out 100, and then counter becomes 102 right here, which makes the condition false. So now that the condition is false, the loop terminates. All right. So now that we set up the iterations, right? Iterations is the amount of cycles in the loop. So we finished the cycles. Now we just have to accumulate this sum variable. We need to make this variable bigger. So one way you could do this is just accumulate sum using this counter over here. All right, so you could say something like sum is now going to be a bigger number. Right, the bigger number is the previous sum plus the counter. All right, so this is the accumulation step. Okay, so let me go ahead and print the let me go ahead and print it so we can see what it looks like. So I'm gonna say sum is currently some decimal number, and then sum. Okay. Let's go ahead and test this out. Okay, save, run. You know what, here, let me print out a bunch of new lines. So each iteration is separated a little more cleaner. So I'll do a print line, bunch of equal signs. Okay, let's see what's happening here. So I'm gonna scroll up to the very top. Let's see. Okay, I have like 100 lines here. Okay, cool. So counter is currently 2. Over here, counter becomes 4. Wait, no. Yeah, counter is 2 here. Counter becomes 4. Oh, I think we did some things out of order actually. So the order of statements matter. I just realized that we incremented the counter too early. You know what I mean? So the sum starts at 0. The counter starts at 2, but the first thing that happens in an iteration is we increment counter by 2, meaning that this counter variable becomes 4, and our sum will ignore 2. So yeah, the order of statements matter. It would probably be more appropriate to increment the sum first. This way we include the initial 2. All right, does that make sense? We want to increment the counter. Accumulate the sum before incrementing counter. All right, so let me change the order of these. Okay, let me zoom out a bit. Hopefully people can read this. Let's go ahead and test it. So Java, and let me scroll up to the top to make sure. Okay, let's see. So counter is 2. Sum is currently, wait, oh, I didn't even save it. Whoops, my bad. See this white circle? This is a very common to forget to save. So let me save it. There it is. Save, test it again. Okay, it should be in the right order now. Okay, let's see. So first iteration, sum is currently 0. Okay, and then sum gets incremented, but we don't see it until the next iteration. Counter is currently 2. Okay, and then counter increments to 4. So it's incrementing there. And the counter becomes 4 plus 4, and then plus 6 equals 12, and plus 8 equals 20. Okay, cool. It looks like it's kind of adding right. We might be off by 1 though. It's very easy to write loops that have off by 1 errors. Off by 1 means that you maybe did an additional iteration that shouldn't have happened. So let's go ahead and verify this. Let me go ahead and print out the final result in the end, just to see, because the number should be 2550. Should be 2550. So let's see. After the loop terminates, I'll say the sum is. Okay, let's see what happens. So save, test, and okay, cool. Sum is 2550. Okay, cool. Yeah, so this is just one way we can do the find out the sum between all the even numbers. There's a bunch of other ways. Some people might have changed the order of these statements, which is valid too, but you might have to change some conditions around. Like you might have an off by 1 error. So depending on your implementation, you might have to change your conditions here. All right. Okay, so with that in mind, hopefully people can try out this next one themselves. This is asking to find the sum of like 1 squared plus 2 squared plus 3 squared. So yeah, you should try that out yourself too. All right, the class exercises are possible exam questions. Okay, cool. So this was just a warm up to make sure folks can do a warm up. Apply a small while loop, because now we're gonna move on to for loops. All right, so here's the cool part. We're gonna move on to for loops, and it's gonna feel the same exact as 2 days ago. All right, 2 days ago we did a couple examples. We did a year simulator that evolved into a compound interest. And then we also did a roulette simulator. It's possible to implement these in for loops as well. So we're going to do the same exact examples. All right. Let's go ahead and introduce this for loop though. I am going through things a little out of order, like these. I'm going to skip over these assignment 3 hints because I didn't publish these yet. But let's introduce the for loop. So this is a different control flow. It's very similar to the while loop though. You can think of the for loop as a simplified while loop. Okay. So in Java, we'll see that the for loop has 3 expressions in here. These 3 expressions control how many times the loop happens. So like sometimes you want to make sure the loop only happens like 5 times. Maybe you want to make sure the loop happens 100 times. These 3 expressions represent the range. Like the range, if you want to go from 0 to 6, then you would initialize it to 0. The condition would represent all the way until 6, and then the incrementer would increment some number. All right, so the control flow is a little different. So I drew some arrows here. The first thing that happens in a for loop is the initializer. We'll do an example on this, so it'll solidify. All right, so the initializer is a way of starting a variable. Like let's say we wanted to loop from 0 to 5. Then we would have to initialize some variable to 0. All right, that would be the initial step. And then the next part of the for loop is it's going to check the condition. A condition is something that's true or false. Okay, so if we're representing 0 through 6 or 0 to 5, whatever, we would have to say the condition is like a while. Right? While the number is underneath the upper bound, we'll do something. All right, the condition determines whether or not we do the body. So if the condition is true, we're going to go into the body of the for loop and perform the statements. Right here, this is the tricky part right here. A lot of people might think it will go straight to the incrementer, but the for loop is a little different. It doesn't increment after the condition. It goes straight to the statements if the condition is true, and then the incrementer is last. Actually, the incrementer is happens after the statements. So the incrementer, this is a expression that changes a variable. The purpose of the incrementer is to make the condition false at some point. Okay, because the loop is right here. We're looping the condition and then go to statements and increment. And at some point, we're going to reach the upper bound, and the condition is going to say, okay, we meet the upper bound. And when we do that, the loop will terminate when the condition is false. All right, so let's go ahead and apply this to a year simulator. 2 days ago, we did a year simulator that simulates the year is 2026, and then we just increment year by year, and then we evolve this into a compound interest simulation. So let's do the same exact thing with a for loop. I'm going to reuse this file over here. 2 days ago, we worked on a file called compound interest. So here's the compound interest program. Let me run it real quick to make sure it still runs. So Java compound interest. Okay, cool. It still runs. This compound interest started off with the years, and then we added the interest later. So let's do the same thing. It's gonna feel like 2 days ago. I'm gonna comment all of this stuff out because I'm gonna end up writing another main that does the same exact thing. Okay, so I just highlighted everything. If you want to comment it out on VS Code, it's control /. So control / will comment out this whole thing. Or you could use a block quote too. A block quote looks like a cassette tape. But yeah, I'm gonna comment this out, and let me do another comment. I'll say this is a while loop. Actually, no, I'll comment it later. But let me go ahead and make another main here. In Java, we can have one main. So that's why I commented out here. All right. So let's start off by simulating years. Like say we want to say, oh, the year is 2026, 2077, and then keep looping line by line. Okay. So let's go ahead and let me actually start off with a for loop. So inside of this main, let me write a for loop right away. So the for loop syntax looks just like the other ones, just looks like the while loop and the if statements. We have parentheses here, and then the body of the loop is represented by these curly braces. Okay. The special thing about the for loop is it takes three expressions. The three expressions represent the range of things. So say we wanted to, let me comment this. Say we wanted to simulate the years. Simulate. Here, let's start small. Let's start small. Say we wanted to simulate a range from 0 to 5. All right, this is saying I want to, for some reason, go from 0, 1, 2, 3, 4, 5. So 6 iterations in total. So with the for loop, we would first start off with the initializer. This is a expression that starts a variable. So here I'm going to start a variable. I'm going to initialize a variable. I'll say int I. All right, I'll say int I. I typically stands for index or iteration. So if you do some reading, you'll see they use I, which is short for index or iteration. It just represents a number. So I will start this off at 0. All right, and then semicolon. That's part of the syntax here. And then now we need to write a condition. The condition tells the for loop when to run it. So in a way, the condition can represent the upper bound that tells the for loop, okay, we met the upper bound, so stop. So the condition here, if we wanted to stop at 5, then our condition here would be I is less than 6. All right, people see what I mean here. So think of this as a while loop. This is like saying while I is less than 6, then we're gonna do the stuff inside. All right, it's just like that. All right, and we do need a semicolon here. So we need a semicolon there, and it's part of the syntax. We could put an incrementer next, but the control flow of the for loop will actually do the statements first. So I'm not going to put the incrementer in yet. Let's put some statements here. All right. I'll put some statements here, like I'll say something like I. So let me print out what I is. Okay, I is some decimal number. And then let me put I here. Okay, so I is a local variable, by the way. It only exists within the for loop. The reason why is because we declared it in the local for loop scope. So yeah, I will not exist outside of here. If you try to print out I over here, it's gonna say not declared because the scope only exists here. Okay, so we just did the statements. All it does is print out the number so we can see what's happening. Okay, let's go ahead and run it first. Actually, well, we're not done with the for loop. I do want to mention that these 3 expressions in the for loop are optional. All right, they're not necessary. So I'm omitting the incrementer right here. You see how it's blank? There's supposed to be some sort of expression that makes a number bigger, but it's actually optional. So if I were to run it, let me go ahead and run it. So I run it, and check this out. I'm actually in an infinite loop right now. It's spamming my terminal, and I have like a million lines probably. So I'm in an infinite while loop. Infinite for loop actually. The reason why we're in an infinite loop is because this condition is always true. I is 0 because we initialized it. So we initialize I to 0. We check the condition, is 0 less than 6? Yes, it is. So we end up doing the statements. So yeah, and we loop up to the condition that this is still true. All right. So let me quit this program here. So Control C. Control C should terminate it. It's like pulling the plug on a program. Okay, so let's do the incrementer. Typically, the incrementer is meant to change the condition. It's meant to make a number bigger so the condition can be false at some point. All right, so for here, the incrementer, I'm just going to make I bigger. I'm just going to say, hey, I is equal to I plus 1. All right, this is saying take the old I, add 1 to it, and store it back to the original I. Okay, so let's see what happens. This is going to change the condition, meaning at some point the middle condition should be false. So let me go ahead and run this. Java. Perfect. So now we have 6 lines, six print statements. Oh, you might want to study this and see how it works. But it's these arrows over here. That's what's happening. We initialize I to 0. We check it, and then the condition is true. So we do the statements, and we're gonna loop this like 6 times. And then at the end of it, I actually becomes 6. So at some point, I does become 6, and we check the condition, and it's no longer true. 6 is not less than 6. So this becomes false, and we don't do the statements, which will terminate the for loop over here. All right, people cool with this so far? Okay, I do want to mention that there's lots of rooms for off by 1 errors. Like off by 1 errors is when you accidentally do an additional iteration when you didn't mean to. And there's multiple reasons for that. The one reason could be like an equal sign right here. If I were to put an equal sign in this condition, this is saying while I is less than or equal to 6. So by putting an equal sign, it's gonna make us do an additional iteration all the way to 6. All right, sometimes this is necessary, sometimes it's a logic error. But yeah, please do keep in mind that off by 1 errors can happen. All right, so hopefully this flowchart makes sense right now. I would play around with it. Our goal was to create a year simulator, like start from 2026 and go all the way to like some future year. So let me just modify these variables. Like let's say we wanted to simulate years from 2026 all the way to like 2030 or something. It doesn't matter what the bounds are here, but let's say we wanted to go simulate 4 years. Let me just change some variables in here. You could use I as a name. I'm gonna use year and start at 2026. And let me erase all of these. Cool, so we're starting over. If we wanted the for loop to stop at 2030, what should we write for our condition? It's just like the while loop. The thing about the while loop, well, while some condition, keep doing something. So the condition here is when the year is underneath 2030. All right, actually we got to include 2030, so I'm gonna put an equal sign here. Okay, and then semicolon here. This is part of the for loop syntax, and then we have an optional incrementer here. In this case, it's not really optional because we don't want an infinite loop. So I'm gonna put a year is equal to year plus 1 here. All right, and here I'm just gonna put a print statement just so people see. So printf, a year is currently some decimal number. Okay, let me go ahead and run this. So Java, and then cool, it looks good. 2026 all the way to 2030. Great, now we're simulating years. Okay, let's go ahead and modify this to gain compound interest. This is just like two days ago. We added a salary. I mean, we added a savings account, and then we added a interest rate and start accumulating it. So if you take a look at the commented main, we're really going to rewrite this same exact while loop, but in a for loop instead. Okay, there's multiple ways we could represent this. One way that's easier to think about is we could maintain some variables, kind of like down here. You see how we're maintaining like a savings account, and we're also maintaining the interest rate. So yeah, we could do the same thing here. We could say, let's go ahead and maintain a savings account. I'm gonna hard code 2000 here, and then maybe we could also keep track of the interest. So I'll represent interest as a double variable. I'm making it a variable because interest can change. Depending on the economy, the interest rates will adjust accordingly. 5% is kind of a good number. It's a really good number, actually. Okay, cool. So we declared two variables. We could just update savings now, because all the for loop is doing statements 5 different times. Right? It's just the for loop is programmed to iterate 5 times. So all we really need to do is make savings bigger inside of the for loop, right? Because the for loop is going to do it 5 times for us already. So we could do it over here, and in the beginning of the while loop, I could say, hey, savings is now equal to a bigger number. It's going to be equal to the savings, the old one, plus the accumulated interest. So the accumulated interest, if you remember from last class, this is your current savings times the interest rate. Okay. So let me go ahead and print it out. So we made it bigger. Let me go ahead and see if it's the right number. Savings is currently some number. Let me put a $sign here. This way it looks like money. Or actually, I shouldn't use D here. I shouldn't use D. I should use percentage. I think it's percentage F. Let me look it up. String formatters. Because with the savings, this is represented as a double. And if you want to include the decimal, then we would use an F to represent it as the decimal number. In particular, I'm going to put a couple more modifiers in there. I'm going to put like a precision modifier in there. So it's going to look like a percentage.2f. You've seen this in the previous 2 assignments. And then savings. Okay, there we go. Let's test this. Oh, let me print out a bunch of equal signs too. Print line. Okay, let's test this. So Java, and okay, cool. So here are 5 iterations. In 2026, we gained $2,100. I mean, we gained $100 because that was the accumulated interest. And then the next year, we gained more. Oh, hold up. I think my terminal glitched. Okay, my bad. My terminal glitched and it printed twice here for some reason. Let me run it again. I think it glitched because I scrolled up and down too much. Okay, the 2205, that looks good. And then next time we compound more. And yeah, this looks good. You could compare this to the while loop to make sure. But yeah, people cool with this so far. This is just one way. You could represent these variables inside of the for loop as well. It's a little more advanced topic, but I'm basically saying that there's a lot of flexibility in these 3 expressions. It is going to be a little harder to read if you did modify it that way. But basically, I'm saying you don't have to declare it outside of the for loop. You could take this. So I'm gonna cut this. Check it out. I'll comment it out. I'll comment this out. You could initialize two things. Oh wait, no, you can't. My bad. I take that back. I was going to do something like double savings is equal to 2000 here. But I was thinking of a different language. I don't think this works in Java. My bad. Let me test it real quick. Yeah, my bad. Okay. But yeah, this is one way you can think about it. Just declare these as like main variables and then update them inside of here. Okay. Any questions so far about this? Let me take a look at the chat. Okay. Let's see. Let me take a look at this stuff. Okay. Cool. So let's do some. Let's play around with this while for loop for a bit. So far, we're just simulating 5 different years. But what if we wanted to simulate a savings account getting bigger until we become like a millionaire? So basically, I'm trying to say, how do we modify this for loop so it stops when we reach a million? Right, so I'm saying simulate compound interest until savings reaches a million. All right, yeah, think about this for a second. How do we modify this for loop? Because currently, the for loop simulates compound interest for only 5 years. Okay. The reason why it seems 5 years is because of these two expressions here, the condition and this over here. So the easiest way we can simulate it until it reaches a million is by modifying this condition. We can just say, imagine this as a while loop. So while our savings is underneath the target. So I'm hard coding 1 million as a target here. So yeah, imagine it's a while loop. While this is true, we're gonna do the statements and then increment the year and then check if the savings is still underneath. Right, if the savings is still underneath, we're gonna do the conditions again. I mean statements, and check the condition again. All right, people see what I'm saying? I'm pretty much repeating this part right here. This loop. The loop happens right here. Okay. So let's go ahead and run this. It should be all the way to a million. Okay, cool. It looks like we did it correctly. All the way until 2153, we become a millionaire. All right. So yeah, this is a lot of text over here. And if we wanted to reach a billion, then you can just add a few more zeros here. So let me see for 1 billion. Let me add 3. It's probably better to give this a named variable. Let me give it a named variable. I'll say target. I'll say our target is equal to 1 billion. And let me just name that there. Okay, let me go ahead and run this. I'm curious. It's probably gonna take a 200 years, like 300 years. I mean, about 300 years, and we become a billionaire. Okay, people cool with this so far? I would suggest playing around with this for loop a bit. All right. Okay. There's a lot of practice, by the way. I recommend when you go through the readings, trying out as many exercises as possible. In 2.3, let me pull the 2.3 over here. So 2.3, there's quite a bit of exercises. I recommend trying all of them. The website does use some sort of their own environment. Like this exercise right here is saying, can you write a program that loops numbers and there's a submission instructions here. You can pretty much ignore these submission instructions because it uses a different programming environment. You already have your own programming environment. It's the VS Code with the JDK environment. So yeah, you can just use your own environment and test to see if you got it working. All right, so yeah, there's a bunch of stuff here. Okay, so let's see. Let me look at some examples real quick. Let me quit this. Okay, let me look at the roulette example to see if we should convert this. Give me 1 second, folks. It might not be appropriate to convert this to a for loop. It is possible to convert it, but I don't think it's appropriate. Let me see. You know, I guess we could modify this for learning purposes. Let's go ahead and revisit the roulette simulator and kind of force a for loop into it. Right? In my opinion, a while loop makes more sense, but it's possible to do in a for loop as well. Basically, the differences between a while loop and a for loop. Well, first of all, they do the same exact thing. Every while loop can be rewritten as a for loop and vice versa. But while loops are more appropriate for things that can possibly be infinite. And for loops are more appropriate for things that are finite. Like if you know the range of how many iterations you want to do, a for loop would be more appropriate because these three expressions tell you what the range is. Meanwhile, with the while loop, it's kind of hard to tell because if you want to see how many times it's going to happen, you have to look at the condition, you have to look at the incrementer inside. But let's go ahead and revisit this roulette simulator to see what we can do. I'm going to simplify this a bit so it looks easier to read. Let's see, 2 days ago we ended off talking about bounds checking. I'm just going to remove this stuff. Bounds checking is like something you can do on your own time. It's a protecting input. So I'm just going to delete the bounds check. I'm going to simplify my code so I can fit more on the screen. All right, so let me play this roulette simulator real quick to see if it still works. So Java roulette. Okay, cool. So it's working. We initialize a bankroll to 200, and now we're waiting for input here. So let me just see if it still works. 10. What number are you betting on? Let me go 0. And then ball landed on 23. So I lost. I lost because it didn't land on 0. And bankroll's now decreased. Okay, cool. Let me just go all in so I can force the loop to quit. Currently, the loop plays infinitely until we don't have any money. So let me just go all in. Let me put in 190 and bet on 0 again. And okay, I lost all the money. So ball in on 7. I lost, and the loop terminates because we ran out of money. Okay, it's possible to represent this as a for loop as well. I did mention that all of these three are optional. All of these three expressions are optional. So you could, instead of doing this while loop here, you could represent this as a for. Oh shoot, okay, let me erase this. Yeah, the VS Code types in like an extra curly brace, but I don't need that extra curly brace because it's already down here. So I think you could just put 2 semicolons here. You could put 2 semicolons here, meaning that I didn't put an initializer in the beginning, I didn't put a condition in the middle, and I didn't put an incrementer in the end. I believe this is possible. Let me run it. So okay, so this is possible, but the Java compiler is telling us that we are never going to touch this last statement here. This is an infinite while loop, infinite loop, by the way. It's a default infinite. So you don't see it, but there's a hard-coded true in the middle here. There's a hard-coded true as a condition. Means that this loop is infinite, and this will never run. So I'm going to comment this last line out real quick just to show folks that this is possible. Let me run it again. Okay, cool. So yeah, this for is working. Everything's optional. It is an infinite loop though, so we're kind of playing forever. So let me bet on 0, and I lost. Let me go all in. Let me go 190. Let me bet on 0 again, and I lost. So now I'm at 0. I ran out of money, but the loop is still going. This is an infinite loop, so we could bet more. Let me play another round. Let's say $25, and then I bet on 0 again, and now I lost. So I lost. I'm at negative 25. I could keep going. 25 and 0. And there you go. I'm now in debt. So yeah, this is an infinite loop. I'm gonna pull the plug on the program. Control C. And let me clear these errors. So if you wanted to reproduce this while loop's behavior, all we really need is a condition. The condition in the for loop is in the middle between the two semicolons here. So all we need to do is say bankroll is greater than 0 here. All right, so there's only one thing in here surrounded by semicolons. This is the same as up here. So let me go ahead and run this Java roulette. And how much are you wagering? Let me go 10, 0, ball in at 15. Okay, I lost. Let me go all in again. So go all in 0, and I should lose. Okay, cool. It landed on 1. I lost. Bankroll is now at 0, and we terminate the loop because the condition is now false. 0 is not greater than 0. Right? Okay. So that's these two lines are the same. This for loop and the while loop. So if for some reason you wanted to do some initializers and incrementer, I did mention that for loops are more appropriate for things that are possibly finite. While loops are useful for things that are possibly infinite. So with the roulette simulator, it kind of makes sense to use a while loop because maybe people play infinitely, or maybe some people quit after like 5 rounds. You know what I mean? Like if you wanted to program something that quits after 5 rounds, it might be appropriate to use a for loop. You could use a for loop and represent a few expressions that says like, oh, round 1, round 2, round 3, and then go all the way until like an upper bound. And when we reach an upper bound, then we can quit the game. So if you wanted to force a for loop into here and do like a certain amount of rounds, let me comment this here. So let's go ahead and say simulate roulette rounds. Simulate a max of 5 roulette rounds. How about that? Okay, so our goal is to simulate 5 roulette rounds. It should quit. The goal is to quit the game after 5 rounds or when the user runs out of money. All right, so it's going to be a little tricky because there's kind of 2 conditions here. The first condition is, did we reach the upper bound? And the other condition is, did they run out of money? So let's focus on the first condition because it's a little easier to think about. Let's simulate a user that's forced to play 5 rounds. So if we want to do that, we would have to make an initializer start at some number, like maybe 0. And then we'd have to write a condition that represents the upper bound, like maybe all the way to the number 5. And then the incrementer, we'd have to do this because it changes the round, right? Like round 1, and then increment to round 2, increment to round 3. So one way you could represent this is by declaring a variable. I'll call it round. All right, let me just initialize it to 0. I'll initialize the 0. In a lot of programming languages, we start counting from 0. So if we wanted 5 rounds, we would go 0, 1, 2, 3, 4. Meaning that our condition would have to stop at 5. So I would have to say round is less than 5 here. This means round is only going to be 0, 1, 2, 3, 4. And once it reaches 5, it's going to stop. All right, but then I do need to increment round here. So I'm going to say round is equal to round plus 1. All right, this is the increment. Okay, so so far, this for loop is, yeah, it's doing 5 rounds. It's forcing the user to play 5 rounds. So let me test it. So how much are you wagering? Let me type in like 10, 0. Okay, I lost. Let me keep doing this. 10, 0. Okay, and then now I'm on the final round. I'm on the 5th round. I lost all the previous ones. So let me do another one. And okay, I lost right here. So I typed in $10 on number 0. Ball in on 14. I lost. And my bankroll is now 150. But you see how the loop terminated? The loop terminated because now we're inside of our terminal environment instead of the program. All right, so yeah, people seeing what's happening here. We forced a for loop into the roulette simulator and pretty much forced 5 rounds. So yeah, this is one way we could represent it. It's possible to do it with a while loop too. It's totally possible. It's probably going to look a little uglier though. In my opinion, the for loop looks clean for finite amounts. So yeah, you see what I mean by clean right here? Like right off the bat, you can tell that this for loop is going to go 5 times. Right? If I'm going to comment here, so because there's a lot of room for off by 1 error. So round is a number from 0 to 5, 0 to 4 inclusive. It doesn't include 5 because we want it to be less than 5. All right. Okay. But let's make this a little more complex. Like, what if we want the user to... What if we want the game to end when they run out of money? Like, currently, if I run the program and say, like, 10, 0, and let's say I go all in right here. So let me go all in, 190 and 0. I lost because the ball landed on 25. And now I ran out of money. But the game is still going. It's gonna go on for 3 more rounds because we're forced to play 5 rounds in total. But we ran out of money. So I could keep betting. I could bet like 200. So I'll bet 200, put it on 0. And now I'm in debt. I'm negative 200. Let me keep betting. Let me go 200 again. Let me bet on 15 this time. And here we go. I'm still in debt. Let me try one more. So let me bet like 400. All right, let's say I'm trying to chase my loss. 400, and then let me bet on 15. And okay, cool. I lost that, and now the game ended. The game ended because we reached round 5. All right, but sometimes you want the condition to stop at some other amount. So the condition is right here. The round is less than 5. So here, think about this for a second. How would we modify this condition so the game would end when the user runs out of money? All right, so or, I'm putting an or here, or when the user runs out of money. This is a little tricky to think about, by the way. It's kind of tricky, but you should spend a couple minutes thinking about it. How do we quit the game after 5 rounds? Well, we already did that right here. Now we need to add in another condition. We want the round to end. We want the game to end when the user runs out. All right, yeah, how do we modify this condition over here? Okay, you might remember from a week ago or a couple weeks ago, we talked about complex conditions like ors and ands. Like, let me pull up this J shell here. You might remember we did like like this AND operator. You remember this AND operator? This is combining two conditions. So if both sides are true, in this case both sides are true, and evaluates the true. But if one of them are false, like this right side is false, this means the whole thing is false. All right, but there's an OR as well. Like if I use an OR, with an OR, only one side has to be true for the whole thing to be true. So in this case, this is true because both are true already. But if one of the sides were false, so like in this case, this side is false, but the whole thing is still true, because with an OR, only one side has to be true. All right, so using this knowledge, would you be able to modify this condition? I would recommend pausing the video and kind of trying it out. It's a good idea to test it before seeing the solution. Okay, so I would represent this like think of it like a while. So we're playing while we're underneath the 5th round, and we're playing when the user has money. So bankroll has money. All right, so here's the condition right here. It's saying play while we're underneath the 5th round and while we have money. So if we run out of money, this whole thing will become false. Okay, so let's test this. I know it's a little tricky to think about because I have an OR here and I have an AND here. All right, I'll explain this in a bit. There's something called De Morgan's laws. It's like a Boolean algebra, but basically this statement is like the same as this statement over here. I'll explain that in just a bit. But here, let me test it. So let me run the game where we now have a complex condition. So let me say, so I started with 200. Let me bet $10, put on 0. I lost. Let's say I went all in. So I'm going all in 190. And then let me bet on 0 again. And boom, the game ended. With 0, the ball landed on 8, and I lost all my money. So the bankroll becomes 0, and then now the condition checks. The condition, well, the round increases first, and then we check this condition. Right? In this case, the left side is true because the second round, and then the second condition here is false because 0 is not greater than 0. So since one of them is false, the whole thing is false, and we end up quitting the game. This condition is false, and we go to the end of here. I should probably bring this "thank you, come again" message back in. Okay, let me uncomment this. Okay, let me test it one more time. Okay, how much are you wagering? Let's see. You go 10, bet on 0, 10, 0. I lost again, and here's the 3rd round. So 10. Let me go 180, 0, and there you go. I lost, and then the game ended. All right, pretty cool stuff, right? You could use a for loop and do the same exact thing as a while loop. All right, I want to clarify this condition here. It is quite hard to read because it doesn't look like this right here. I do guarantee that this English sentence is the same as this Boolean condition here. Right? I know it looks confusing because there's an OR and an AND here. So they're algebraically the same, or logically the same. If you're curious why, there's something called De Morgan's laws. De Morgan's laws is a way of representing logic in different ways. So it's got something to do with Boolean algebra. Boolean algebra is pretty much what we're doing over here. Where Booleans are true or false. So we're doing operations with true and false. And with De Morgan's laws, there's a way of representing certain things equivalently. Let me see. This is a little, let me look for an easier one to read. Okay, this is a little harder to read. Let me help summarize this for folks so you see what I mean. Let me pull up a notepad actually. Okay, just gonna pull out a scratch pad here. Okay, so De Morgan's laws go something like this. Like, let's say you have P and Q. So let me go P or Q, actually. I'll go P or Q. Think of P as some sort of Boolean operator, a Boolean value, I mean. So P is true or false, right? P is true or false, and Q is true or false. These are Booleans. Okay, P and Q are Booleans. If we were to take the whole thing and negate it, so in Java there's an exclamation mark. The exclamation mark is a negation. It's saying make this whole thing opposite. So if this whole thing was true, then the exclamation mark would make it false. If this whole thing was false, the exclamation mark would make the whole thing true. So De Morgan's law says that this condition, which is pretty much right here, is algebraically the same as distributing the negative, distributing the negation. So you could distribute it to P, but then the inner operator changes to and. So yeah, De Morgan's law pretty much says that both of these are the same. You could test that out on your own. You could brute force and prove it over here if you wanted to. Like let's say P or Q. So let me go true or true. And then let me put a not here. Whoops. All right, so this is like a Boolean algebra here. The order of operations says do the inside first. So what is true or true? It's true, but then this false is gonna make it false. Okay, and if I make this false right here, what's this gonna be? It's still false. You see why? But because the inner is true, but it gets negated to false. All right, so you could test this out. Like you could prove not really prove, but you could brute force prove it. Like if I were to test this one here, not P and not Q, this is the same as saying not true and not false. And this becomes false right here. So yeah, you can try this with all of the variations, and it's gonna be the same thing. Like let me try one more. Let me try both false actually. Let me try false or false, and then let me negate it. So if you think about it, false or false, this is false because none of them are true, but then this negates it, it becomes true. All right, this is the same as this second one over here. We can distribute the negative sign and change the operation. So this is going to be not false. I mean, yeah, not false and not false, which gives us true. All right, so yeah, this is De Morgan's laws right here. Earlier I pulled up the Wikipedia. It was a little harder to read, but in summary, it's saying that these two expressions are equal. All right, the takeaway there was just to explain this and the or right here. This is saying, yeah, with De Morgan's law, this is the same as this over here. Okay, any questions about this so far, folks? Yeah, okay, pretty cool stuff, right? Okay, what should we do next? Cool, so we talked about the for loop. right. Next up, we should end class with a class exercise. So let's spend the rest of class doing this. I'll let folks try it out themselves, and then we'll go over a couple possible solutions as usual. And then I might give some hints on the next assignment. I haven't published it yet, but I might have to make a separate video for this. A separate, like, 15-minute small video. But let's end class off on this for loop warm-up to make sure folks can apply this. This warm-up is going to be the same exact one as in the beginning of class. Earlier in the beginning of class, we asked folks to do a while loop that makes a number bigger. Let's see if we can do the same thing with a for loop. All right. So yeah, let's spend 15 minutes. I would call it like for loop warm up. So let me help folks get started on this. For loop warm up. This is a prerequisite for next week, by the way. It's very important that folks fully understand how to do these before we go on to next week. So yeah, so see if you can spend some time at least thinking about it and trying it out. Let's spend 15 minutes and we'll come back to this. All right, feel free to let me know. For folks on the Zoom, feel free to unmute yourself if you're having trouble with anything. Let's go put up a 15-minute timer. Okay, I'm gonna pause the recording right here.